In this installment, I am thinking to add some slight movement of the attacking entity. So when an entity attacks another entity, right now we play an attack animation, which I can show. So for example, when I approach an enemy here, the enemy will attack me with a little scratch animation there, but the enemy itself doesn't move. And also when I attack, I play my little animation, it plays its animation. It would be nice to make the attacking entity advance like half a tile in its facing direction and then retreat around the time that it takes to do the attack animation. So I'm thinking of leveraging what we already have, the timers that we already have for attack animations, and just kind of modulating the position of the attacking entity using a ratio created by the time left on the attack animation timer. So basically we can just go into render entity with facing direction. Right now, currently, we just get an atlas index for a player or an enemy based on their facing direction. But we do need to check the entity state here now. Here we set up the source rectangle, which is going to stay as is. That's a source rectangle into the backing atlas. And the destination, we're going to modulate either the X or Y or potentially both based on the facing direction. We don't have diagonal facing directions. We only have up, down, right, and left. So for this particular feature, we are only going to modulate X or Y, but not both. So if ev.state.prop is attacking, then we need to switch on the facing direction, and maybe I'll create a kind of support routine. I'll implement it right here, then I'll extract it out into a support routine. Wow, switch. This is not C or C++. So if we are attacking, we're going to get some ratio, set up some ratio here. The ratio will be the number of seconds left on the animation timer divided by the animation attack cooldown. Like the position offset, we're going to compute uniformly for any direction, and these directions just determine whether we apply it to X or Y and what the sign is. So I'm thinking the maximal displacement will be half of a tile width. Tile width in pixels divided by 2. And then we just modulate this based on the ratio. So we're going to use a sinusoid. Just to be simple, we'll use a sine. Jai probably provides it. Do I call it Jai math? I call it Jai math here. The displacement is going to be the max displacement multiplied by Jai math sine, Jai math pi, and then pi coefficient is going to be 1 minus the ratio. I think that's correct. We can just graphically confirm that though, but first I need to finish the switch here. So if the case is up, then we'll have destination.y minus equals, this is going to be a position in pixels. I think that's fine. Minus equals displacement, right? So there we go. He attacked, I attack, he attacks, I attack. This is pretty cool. All right, they do attack. It added some life to it. That's pretty nice. I like that. But then just to leave off with some ideas, essentially we can change the math function to add an acceleration to the initial part, like toward the maximum displacement, or maybe a sharp maximum displacement and then deceleration as you reduce displacement and return back to the starting position. You can do something like that. Thank you so much for tuning in. Peace.